righty, super excited to have everyone join us here today. A simulation conversation diving into some of the technical details of simulation and what's available out there for the SolidWorks users. We're joined by Drew from Dassault Systems, and we have Mitch from Swift Solutions with us today. So just to start right off, in terms of simulation, SolidWorks users know SolidWorks simulation. Is there more options out there than just SolidWorks 4 in the SolidWorks domain?
Yeah. Oh, man. So there are quite a few options that they now have available to them. So over the last 2 years, Dassault has expanded the capabilities that are available in the SolidWorks portfolio of tools. So traditionally speaking, we have our SolidWorks simulation tools. It's a solver called Cosmos, for those of you that have used it before. It's been around for a long time. We can now get a little bit more into what I'll call the higher end of simulation. And I'll show you a little bit more as we talk through this little presentation I've got here.
Yeah, so I know that those higher end tools, people may have heard of the 3D Experience platform, and those are hosted on that platform, but they're fully connected to SolidWorks, and we'll take a look at that today. But tell for those aren't familiar with the 3D Experience platform, or some of those who have heard of it a few years ago and starting to hear more and more, tell us about what that platform really is.
Yeah, so I'll go through my little presentation here. This kind of covers it as well. So as a company, Dassault has what we call a lot of brands. So you can see on the screen here, we've got some familiar names here. SolidWorks in the upper left-hand corner there, that's a brand. That is what we associate this with. Now, the 3D Experience platform itself, how it works, you can think of it, well, kind of like a cell phone, right? So we have a united platform that has all of these options that we can do lots of different things on, like my smartphone. I can do banking. I can talk to my friends. I can post stupid stuff on the internet. Like, I have a lot of options, right? The 3D Experience platform works in a similar way, where I have this fundamental platform, and then I have apps that I can use to access whatever I'm trying to do. Aside from posting stupid things on the internet, would not recommend that here, but otherwise that's fine. Though the two disciplines, of course, that we're going to be talking a little bit about today, we've been more mentioning the SolidWorks side of the equation and SIMULIA, which is that high-end portfolio of tools that I was talking about.
Awesome. And I jumped right in, started talking about simulation, and people could perceive what simulation may mean for them. So let's just all get on the same page. I know, Mitch, you're talking to people a lot on the sales cycle of people who have needs for design and simulation. Based on just your understanding, how would you define simulation? And then we'll take how you would define simulation. There's different perspectives.
Well, Drew, I'm sure you have a better definition than I do.
I doubt it. Let's find out.
I would define simulation as just looking at the overall CAD, looking at the overall product, and just being able to use either force or different dynamic changes to understand how how the assembly would be affected.
So basically just looking at how things are going to perform before they're actually made.
Yeah.
Yeah. That's how I would define
Okay.
it. So we're on the same
Drew.
page. Yeah.
And there's a lot more technicalities behind it. I mean, how that's achieved, and different softwares have different technologies, but ultimately it's all the same math behind a lot of that. And it's a big part of simulation software really is how connected it is, and how easy it is to get your models in there, and how easy the workflow is and efficient. So SolidWorks users have traditionally been very connected to their usability of the CAD platform, just being able to get in as a brand new user to SolidWorks and take off and start designing and self-learn to some degree. There's always efficiency to be learned in training, but does that carry over to the SolidWorks simulation options as well?
It does. So there are different ways that it is accessed, where SolidWorks users may be more traditionally familiar with the SolidWorks simulation portfolio, where it is a tool that is embedded directly into your seat of SolidWorks. This is it's a separate tool. There is a handshake that occurs between the tool itself and the product, but fundamentally you still access it through your seat of SolidWorks.
And that's that advanced, the SIMULIA-based simulation that you're talking about.
Exactly, yes.
There is still those options for the SolidWorks built into SolidWorks, and then exceeding those capabilities even beyond what SolidWorks Simulation Premium can do is those SIMULIA-based options.
Exactly, yes.
Now, are those for people that are hearing about them as new, how long have those been around? Are those new technologies?
Oh my gosh. Well, so Dassault Systems acquired the solver for the SIMULIA technology in 2004. And it had been around for quite a while before that. So this is not new, but it's new to us. So those of us in the SolidWorks channel here, we now have access to these tools, which gives us a little bit more power to make design decisions, to figure things out, to understand how your part's going to work, all kinds of good stuff.
And that's what the 3D Experience platform really is all about, giving SolidWorks, I mean, not just SolidWorks, but when it's brought to the SolidWorks community, giving them access to tools that they have never had access to, that have been around for years. And it's scary to hear like something that you're so foundationally connected to, and it's like it's not going away. It's expanding and connecting to additional tools. So you still have access to all the same tools that you've had in SolidWorks, but way more capabilities in terms of beyond simulation. It's simulation manufacturing. It's all sorts of things, as you see here.
Yeah, absolutely. And it's got quite the capability. So it gives you a lot more freedom to do some interesting things.
Now, when it comes to simulation, not necessarily specific of like industry, but like what generally would qualify somebody to need simulation? Is it more than one time a year, or is there any kind of equation that you can start to look at?
The equation is how much time is being spent on things that can be fixed with simulation. So let's say, for example, I have a casting that I'm producing, and it is constantly failing at a, we'll say, like 30% rate. So I have a scrap rate of X, or of 30%, or I have a failure rate of 30%. Those are two different things, but we can use them both in different examples. I can use simulation to either predict how this part's going to fail and reduce manufacturing defects, or I can use this before I even design the thing, or before I even make the thing, so that it fails less, which means that I have less rework to do. Because frankly, that's, depending on the industry, that's pretty unacceptable. I picked a very high number on purpose. But understanding how much time you're spending on rework, how much time you're spending on warranty issues, things like that, problems that could be solved before you even make something, man, that's simulation's wheelhouse. That's how you use it. And that is the thing you should be keeping in the back of your mind as to whether or not you should get into this. I'm an advocate of everyone having simulation software. I enjoy it, and it makes a lot of sense to use, but that is the equation I would use.
Yeah, so I know we were taking a look at some results of what you can do with simulation here before. Do you mind pulling those up and taking a look at making a visual representation for people here that are watching in?
Yeah, why don't I pull up a fun little slide here? So this is just a quick little overview of some of the things that you can do within simulation, and all of these videos are supposed to start. Please don't fail on me, of course. Thank you, that's fine. Oh, they're moving. Okay, there we go. Just took some time. So there's a lot of things that you can simulate in our solutions and simulation software in general. So I've got some examples here. We can pick some of the ones that I find the most interesting. Honestly, the top or left-hand corner of the screen there, the bird strike. There is a test in the aviation industry where they literally fire a frozen chicken out of a cannon. That is a simulation of it.
Well,
yeah, which is,
I don't know why you'd want to computerize that. Let's keep that going.
Yeah, it's rad. I don't need to see the actual chicken. This is a lot better. And then some of the other interesting things that we can do within the software from like a manufacturing perspective. So you can see the example of a blow molding case here. So basically we have an injection molded piece. In the injection blow molding industry, that's called a paraffin, and you blow it out and you expand it. That is an incredibly technically complicated procedure. We are dealing with anisotropic material properties. We're dealing with high residual stresses. We're dealing with a lot of stuff. So it's one of those cool things you can do. Another pretty interesting example we have here is in the left-hand side is blade damage. So what is happening is I can actually simulate how something is going to, we'll call it a catastrophic failure, right? It's failed beyond the point that it's usable. And what if that happens, I want to see if a catastrophic failure is going to cause any other bigger issues. So like, yes, it's a scary word, but basically that just means it fails completely, right? I want to make sure those blades aren't going to kill somebody if they come off, that sort of thing.
I mean, we're looking at results from the higher end SIMULIA-based simulation. how far does SolidWorks simulation inside of SolidWorks interface, how far does that go when it comes to like failure testing? How close to this type of result can you get?
So I have a handy dandy little slide to talk about that too. Though a lot of the things that you see here, in fact, all of these things, these examples that you see are beyond the capabilities of SolidWorks simulation. And just barely so. Like it's a wonderful tool, but it does have some limitations, which is addressed by these sorts of things. So this is it done in our tool called Structural Mechanics Engineer. And I can kind of talk a little bit about where those portfolios fit in. So we have 3 portfolios of tools. We have our SolidWorks simulation desktop tools on the levels of Standard, Pro, and Premium. Those are what SolidWorks users would be most familiar with, traditionally speaking. Now, we also have a historical portfolio of tools that are now of access to us, the SIMULIA desktop tools. That is to say, it is not part of the 3D Experience platform, but it is the same bones, the solver behind it. So it's the same code. And I've put a couple of things in here that are not all necessarily on the structural side of things, but the structural comparison is just the easiest one to make. And then, of course, we have what is available to us in the 3D Experience platform. And this is on an increasing scale of complexity. So the tool that was used for those particular simulations was Structural Mechanics Engineer at the top of the screen. That is our flagship product. There's some add-ons to it as well, depending on what you need. So you can add a durability add-on to it, which if you're doing really complicated fatigue analysis, that is something that you should have. But for not everybody, it's the kind of point here is that we have a very scalable product in many facets. So both on the desktop side, the SolidWorks simulation desktop tools, and on the 3D Experience platform, they're both scalable tools. So if I need a little more, I can add some more. If I don't need that much functionality, I don't need it, right?
Now, with drawing that comparison between that SolidWorks simulation premium and that structural mechanics engineer and that failure conversation that we were just talking about, like I know a lot of people, like even at the base, any of these you can go up to yield, and then you can get into some nonlinear materials. Can you, to any degree in SolidWorks simulation, get to where you're actually seeing breakage in terms of catastrophic failure?
Not like what I just showed. Actually, this is my favorite answer to give. It depends, because that's just so indicative of the simulation like tools, right? Because it depends on exactly what you're trying to do. But it's like you said, if you have a part that you bring it right up to that failure point, you can see it, and I can say, oh, that's a fun rainbow colored part, and it's real red right there. It's probably going to fail right there. But I can't predict how it's going to fail. I just know that it's going to fail.
Not going to see it like tear apart.
Yeah. So talking about that example that we had with the propeller and the catastrophic failure, there is just no way that I could predict something like that. And one of the things that defines being able to predict how things will fail in that manner is that we call it element death. So basically what happens is once an element for those that are unfamiliar is a small portion of the overall simulation. Once that little tiny piece hits its failure point, it is deleted. And it is deleted in such a way that it causes the rest of the part to fracture, which means that you can get more accurate real-world results because that's what kind of happens in the real world. So that's how we predict catastrophic failure, right?
Mm-hmm. Now, when it comes to SIMULIA, is there any kind of specific factors that you would be on the lookout for if somebody's already in SolidWorks simulation? They already have SolidWorks simulation premium, for example.
Yeah.
Other than catastrophic failure like that, what other types of factors would you be looking out for that would qualify you to jump up to a more advanced tool? So
that's a great question. And there are definitely a lot of people that hit the upper edge of the tool. And you can get away with a lot in SolidWorks simulation premium. Even so, you can figure out where you can see those predictions of failure. But some of the big indications, if you're going to need to make this jump, are when you get into an incredibly complicated contact problem. So you have a big assembly and you're trying to figure out what the heck's going on with it. That is a pretty good indication that you should use the higher end tools. The other indication would be anisotropic materials. So rubbers, composites, things like that. The solver within the 3D Experience platform and the SIMULIA desktop tools is a lot better equipped to handle it. It is, in fact, a lot more efficient solver, too. So you actually can improve, with using the same amount of cores for your desktop, you can improve the efficiency of the solve exponentially by moving from the Cosmos solver, the solver for SolidWorks desktop sim, to the 3D Experience or SIMULIA tool. Again, it's exponentially improved, truly.
Can you go back to that other slide with the other examples?
Oh,
of,
yeah.
the results.
Totally.
I want to visualize that tube crush, because in that bottom rightish, just for everyone to take a look at, when he's saying something crushing and the contact associated with, or even the bottle with liquid crush, it's really, unless you've been in simulation, how cool that is that it can simulate self-contact like that on its own body, and you don't have to really define anything with these tools. I got started with SolidWorks simulation and have played around with the SIMULIA based and I'm getting more and more familiar with those. And when I was playing around with some of the self-contact things where part is crumpling and it's coming in contact with itself, like a can crushing or anything like that, it's insane to see that being simulated and actually how that's going to end up, the results of it.
Actually, all of the results here, most of them on the bottom here, are examples of that tool. So that functionality within the 3D Experience and SIMULIA portfolios is called global contacts, and it is quite literally a click of a button. So like this wire crimping example that I'm going to run in the bottom left-hand corner of the screen here. If I were to set that simulation up in SolidWorks, I would have to define every single surface, and I would have to know exactly where each wire connects with another one. I can't. Like, you can see they kind of get all jumbled up when you do that. It would take, I could theoretically do it, but it would take hours to set up. With global contacts, it's seconds. It's a checkbox. And that also, global contacts applies to parts itself. So if we look at the complex contacts in buckle, with that profile there, that is an automotive seal. That is establishing those contacts among itself, and it can figure out exactly how it's going to work. That study took like 10 minutes to set up. It's amazing. I've been in the simulation industry a long time. This stuff is truly mind-blowing.
Yeah. Another thing with that is worth mentioning, when you get up into those SIMULIA-based, the higher complexity problems, you can also jump into some of that cloud solving capability where you don't have to have it running on your computer. You're able to set up the next simulation while that's running on cloud computing, and that's built right into the offer as well. So when you get up and running with those, you can offload that off of your computer, and you can even have additional cloud cores beyond what your computer is even capable of, and really accelerate that solve time. So that's another capability. When you're getting into more advanced capability or simulations, more and more you're going to need something like that. You don't want to wait 3 days to find out the results.
Nobody's got time for that. Yeah. And the better thing here too is because this is a handshake, so it is a separate program. It's off on the cloud. It doesn't have to be. You can do it on your computer too, but it doesn't tie up a seat to SolidWorks. This is offloaded. You can run your simulation, and then you can go back to designing. So you're not tied up with resources. You're going to save yourself some time. You're going to save yourself on some resources. Yeah,
and you can still have SolidWorks simulation for all of your more basic cases, and bring something like this on board to your team for a quarter at a time. You've got a big project with complex problems, and then use that alongside of SolidWorks simulation even. And even we'll see the handshake between SolidWorks, but connects very, very well to SolidWorks data so that you don't have to export and import, and if there's a change, go back and start the whole simulation setup over. So that's a big advantage of interconnectivity and having all of these tools connect together on the platform, and that's really the whole vision of it.
Well, and even having this for simpler problems, you're still offloading it. And it's still going to be a lot faster than if you just did this right there. The handshake is pretty seamless. I'll show it in a minute, but yeah, that is, it's not just for complicated things. The big advantage of our portfolio of tools, whether that be any of the ways that we distribute it, is scalability. You have what you need. You can get more if you need it, and you can bring it back down if you don't.
Now, do you have any numbers? And it's fine if there's no specific numbers, but core for core, if you were to compare SolidWorks with, and this is using the Abacus solver, correct?
So this is using the Abacus solver, and I do have a specific comparison. It's a customer example, so I can just tell you the numbers.
Just a number.
Yeah. So for large contact assembly, this was a large assembly of like a manifold for an industrial equipment application. We ran the exact same study in both SolidWorks Premium or SolidWorks Simulation Premium and Structural Mechanics Engineer with the same amount of cores. It was 8 cores, right? The large contact assembly in SolidWorks Simulation Premium took 120 minutes to run. It took 18 to run in Abacus. So when I say exponentially, I mean it. Yeah. That is where it shines, right? It is truly a much more efficient solver. And you're still getting great results either way. Yeah. It's just, man, the time saving.
Yeah, and it's easy to lose sight of, I can carry this out with a simpler one, but if you do some math on what that time is, that can add up quick. In terms of core for core, another thing with SolidWorks simulation is I know the SIMULIA ones are pretty linear. The more you add, pretty linearly drops down your time. How far can SolidWorks simulation go when it comes to core utilization? Is it the same way?
Not at this time. So you are limited to what you have on your machine. And I think that there's a hard limit of 8 cores. It's just what you've got, There's certainly some ways around it, but that is a limitation of the solver currently. Which
and that can be plenty for a lot of simulations. I can still get you results really quickly. But it is something to consider if you're talking about like a car crash and the amount of contacts and how big of a mesh that would be. Something like 144 cores would make a huge impact on that. Indeed.
And where this really shines is in those nonlinear applications, or specifically like fluid dynamic applications. Using more cores would help with that. And our 2 big codes for that are, of course, for fluid dynamics, engineer flow, or our plastics product. But for this sort of thing, too, this is very helpful to have more cores.
Yeah. Awesome.
Yeah.